Hey guys, you can't see me this time because I want you to be able to see stuff without reading it backwards. I was thinking about the law of sines, right? I told you a formula to make it work. Howdy doody. But did I prove it to you? I didn't prove it to you. So I took a random triangle here. As you can see, triangle ABC. And let's make it into something I can work with. Law of sines has to do with trigonometry. No right angles in this triangle, so let me make one. I'm going to drop an altitude down. As you can see, going from B to the opposite side, that's going to create a little 90-degree angle on both sides. Now, let me call that, actually let me name all the sides in my triangle. Let's keep it easy. Across from vertex A, we're going to put little side A. Across from vertex B, we'll put little side B. And across from vertex C, we'll call that little c. But what about the altitude? Next letter in the alphabet would be D. Let's call it D. What the heck? A little d for my altitude. Now, as you can see, I've got two right triangles in there. And let's talk about them with respect to trigonometry. First of all, let's start at A. What the heck? If I want to find the sine of A, sine of angle A, well, that's got to be equal to the opposite divided by the hypotenuse. Well, opposite A is D, and the hypotenuse in this one side, just this triangle, this guy, D is my opposite, C is my hypotenuse. Sine of A has got to be D over C, just a ratio. Now, what if I wanted to find the sine of C? Just for kicks. Check it, the sine of C, well, that's opposite over hypotenuse. Well, opposite C, that'd still be my little d over here. And the hypotenuse just in this side, well, that's little a. All right, so I got these two ratios. The sine of A is d over C. The sine of C is d over A. You know what? I don't like fractions. You like fractions? Nah, let's get rid of them. Let's drop a 1 under this guy. Let's cross multiply to find out that C sine of A equals D. If I lost you, then don't stress this video. But if you're still with me, check this out. Forgot to circle my cross multiplication magic there. If I was to take sine of C, get rid of the fraction, do a little cross multiplying, A sine of C also equals D. Because hey, D times 1 is just D. Check this out. Do you see what I see? Do you notice something special about my two values right here? Sorry for my shakes. This D is the same as this D. And when two quantities equal the same amount, they've got to equal each other. Gosh, what is that, transitive? Is that what we're talking about here? Well, that means, let me take this up a notch, that C sine of A has got to equal A sine of C. If you're with me so far, it's looking good because we've almost proven the law of sines. Check this out. If I divide both sides by little a, my a cancels out. Let me get a good full view shot just in case you missed that one. Let me rewrite it as C big sine of A over little a equals just my sine big C. You know what? I want to get that C on the other side. So if I divide one side and divide the other side by it, goodbye, little c, and I have proven to you the law of sines. You see, the sine of angle A divided by side A is equivalent to the sine of angle C divided by little side c. It only took 4 minutes. It wasn't rocket science. Let's take a look at how we got started. We dropped an altitude. We found out the relationship between the sine of A and the sine of C, found out both of those quantities were equal to that altitude, did a little bit of simplification, and presto, the law of sines has been proven. Goodbye, my children. Please stop staring. That thing follows me everywhere. Have a great day, and I'll see you in the morning.